If you gave it enough of this.
All right, thanks for coming today. We're going to look at creating Kali links, or putting Kali links on a bootable USB. There's a lot of different reasons to do this. Mainly a bootable USB lets you boot to the operating system on the USB without affecting the operating system on the host at all. So if you have a laptop and you boot to the USB, when you're done you turn it off. There shouldn't be any problem booting back to the regular operating system. So it's a good choice if you want to try out a new operating system, or if you want to use the computer with an alternate operating system but have it go back to the way it was when you're done. It comes in handy in pen tests when you want to use a certain piece of equipment, say a laptop that maybe has a special radio in it, or there's something about the equipment that you need, but you don't want to use, say, the Windows operating system that's already installed on it. Maybe you're not allowed to erase it. Maybe you have to leave the Windows alone. Yes?
Or if you only have temporary access to a machine, you want to quickly copy off the same system file.
Yeah, that works too. So, yep, if you're doing a device pen test, then yeah, you definitely would boot using the bootable USB, because it gives you access to all the files on the host operating system. So if it's Windows, for example, you can get to the same files and such, whereas usually when Windows is up and running, those are locked. So Kali is a pen testing distribution. It's actually a regular Linux operating system. It's Debian 6, and it acts pretty much just like the regular distribution of Debian for the most part. But the difference is it's pre-installed with a whole lot of programs that are used when you're doing vulnerability assessment, auditing, pen testing, different types of work in the security field. So you don't have to download and install all those programs, and more importantly, you don't have to configure them and get them working. That's really where Kali saves a whole lot of work. Some of the programs have a lot of dependencies, and they're really tough to get working. I got some links that I'm going to post later on, and those go out to the Kali website, where you can download the ISO that we're going to use today. And then there's also documentation at this particular link on how to set up a bootable USB. They have a nice guide already set up that'll walk you through it real quickly. So refer to that if you want to see written instructions after we get done today. I've also included a link to an image writer that we'll look at later. This is how you would copy the ISO over to the USB if you're using Windows. And then 3 links to the Live System project, the Debian Live System. That's what the bootable USB uses to get booted and running. And it's also how it maintains persistence, meaning that if you do something on the while you're in the USB, say like create a file, for example, and you don't have persistence running, then when you shut down the operating system and take the USB stick out, you've lost all your changes because they were just in memory. But if you make a persistent USB, then those changes will be saved, and when you reboot back into the USB later, you'll see that your work is still there. So those are some links for, we'll call it some extra reading, if you will. Here's a couple of commands we're going to use. I just wrote them down for reference later on. So we already talked about what Kali is. Talked a little bit about what a live USB is. Where it came in handy for us recently was we had to use a particular laptop because it had certain network cards in it, but we didn't want to use the operating system. In fact, the operating system that it had kept us from getting onto the network and doing the work because it had some registry injuries and some drivers that prevented access to the network. But if you boot to a USB, then the host operating system wasn't running, and it had no say in whether or not we connected to the network. Worked out very well. So there's some assumptions we're making. First of all, we're assuming that you have enough space on this USB device. This is mostly important if you're going to use persistence, because obviously as you add files to the USB, you're taking up more space. The Kali installation itself is approximately 2 gigabytes. I'm not sure if it's slightly under or slightly over, but it's right around that mark. So you would likely need a USB that's at least 4 gigabytes, but really to do persistence, you're going to need more, like 8 or even greater. 8 works fine for everyday work. I think they're running about somewhere between $10 and $15 for 8 gigabytes right now. We're also going to assume that the host that you plug the USB into allows you to boot from a USB, and we're assuming that the USB itself is a bootable device. So just for reference, I've found that as long as you have access to change the boot configuration in, say, the laptop or whatever it is you're booting with, and if you use a name brand USB drive, I haven't had any problems. So some people will have problems in that they're locked out of their BIOS settings and they won't be able to change the boot parameters to boot from USB. That might be in effect on, say, like a corporate laptop where they don't want you booting from USB, because then you would be able to get to the host operating system files, assuming it's not encrypted. So here, the basic steps are written out on this, I guess, cheat sheet, and we'll talk about each of these, but we're going to just do them in demo. So I've already inserted the USB and the device is recognized. So if I do like a D message, we can kind of see that the device was recognized as a Kingston data traveler, and eventually it was assigned the device label of SDB. And there was already a couple of partitions on it. See, you can see down here that one of the partitions was actually a Linux partition at ext4, and it was mounted by the operating system. Not to be confusing or anything, but I'm actually using a Kali Linux virtual machine to make a Kali Linux USB, so that's why it says Kali Linux in the background. We're not booting from the USB yet. We haven't created it yet.
Jeremy, just it's actually still that it's capturing right, but it's distorting it, and some stuff at the bottom is being cut off on the display. You highlight something, but I'm seeing it there, but not up there.
Okay. All right, let's do it again. D message. So I was referring to the Kingston here, and the drive letter was assigned approximately there. Well, I'll say drive letter, that's awfully Windowsy. The volume label was assigned here. And then down here was where it had mounted the second partition, SDB2. So you can see there's also an SDB1 partition on it as well. All right, so first thing we're going to do is we're going to clear whatever partitions are already on this USB. Since it's been used already, it's already had some partitions put onto it. We can use gparted to do that. If it's a new USB, shouldn't have to do this. If it's already been unformatted or reformatted, it should be fine as well. So after carefully checking in dmessage what the device name actually was, I'm going to open up gparted on device. SDB, which is under, in Linux, it's always going to be under the dev directory, except when it's not. Seems like every time I say always, there's some corner case. So gparted is showing that we have two partitions. We have this partition here on the left, SDB1, and then the remainder of the drive appears to be taken up by SDB2. And just as kind of a sanity check, this volume is about 8 gigabytes. So again, kind of an indication that I've got the right device. I'm not picking my hard drive or something like that. I'm about ready to format my hard drive. Right, so just going to kind of take your time. So why don't we just go ahead and delete these partitions. So the space is now unallocated. The entire space is now unallocated, the entire 7.5 gigs that are available. And when you get it set up how you want, you're pretty sure that everything's correct, you hit the green check mark to apply the changes, and then format your hard drive, right? So, or hopefully the USB. All right, so we'll close that. Okay, so this USB should be clean now, ready for installation. Okay, I've gone ahead and made a copy of the Kali ISO, but you would need to download that from their website before you got started, or now. So I probably should mention that getting this USB recognized in the VirtualBox took a little bit of work. If you're booting to your host operating system and doing this, you're probably going to have full USB support without any kind of need to configure anything, and everything will be fine. But if you're running Kali in a virtual machine like we are today, there's a couple of pointers that might help out a little bit. First of all, when you plug the USB into the host, generally speaking, the guest operating systems like Kali in this case are not going to recognize the USB. They're not even going to know it's there. The host operating system is going to capture that USB device, and you can use it in the host. In our case, it's Windows. You can use it in the host all you want, but it's not going to show up in the guest, which in this case is Kali. There are some exceptions I'll point out here in a second. So generally what you would do is you would come up to Devices and click on the menu and then go to USB Devices, and then you would check the USB device that you would like to have taken away from the host and virtually plugged into the guest operating system. At that point, VirtualBox will do its magic and it'll make it appear as if you've physically plugged the USB into the virtual operating system. And at that point, that's when you would do the D-message. That's when it would show up. Now, since I want to always use this particular USB device with this virtual machine, what I've done is I've gone into the settings inside of the VirtualBox Manager for Kali, and I've gone down to the USB section. I've created what's called filters. What a filter is you would click the plus symbol with the USB plugged into the host so that it can recognize it, and then you would create that filter by clicking on the device that you want to create the filter for. What the filter does is when you plug the device from that point forward into the host operating system, into the physical machine, VirtualBox is going to intercept that device and keep the host operating system, Windows, from recognizing and plugging the device in. It's actually going to be virtually plugged directly into the guest automatically. You won't have to go up there and say devices and check the device off. That can be useful in some circumstances where the host is grabbing the USB device away from you and then locking it, and then you can't get it away from the host and connect it to the guest. So USBs are not really a problem, but I have had problems with some Bluetooth USB devices, some network cards that you plug in via USB. You know, Windows grabs that device so fast that you can't go back to the virtual machine and go up here to the devices and check off the device fast enough to grab it before Windows has already taken the device and locked it. I have more of a problem with that in Windows XP than Windows 7. Windows XP is quick to grab those devices and lock them, and then you'll get a message that says, when you try to check it off up here to connect it to your virtual machine, you'll get a message that says the device is busy and you can't connect it. So filters can definitely help in those cases to prevent the host from getting a hold of the device too quick. If you're not virtualizing everything, then none of that's necessary. So, all right, so let's get started. I think I downloaded the ISO to a shared folder. So let me just double check that real quick. Yes, so it's this ISO here. And it's pretty good size. Like I said, it's approximately 2 gigs. Somebody can crunch those numbers in their head. They can tell me if it's bigger or smaller. So I have a feeling a 2 gigabyte USB won't work though. All right, so we're going to copy this file, the ISO file from the Kali website, and we're going to copy it directly to this unformatted USB device. Oh, sorry, is it cutting off at the bottom?
Yeah.
Is that better? Okay, so there it is right there. You wanted to do the math, right? Okay, there's the number. All right, so we'll go ahead and copy that over. You can use DD to do this, so you can say my input file is going to be media, the shared folder in our case, and the Kali file name, and then you would say the output file is, be careful, dev SDB, and then you can give it a block size of 512 bytes. That'll work just fine. It'll take a while, and you will not be able to see the progress while it's doing it because DD just kind of hangs until it's done doing the copy. So you just have to go get a cup of coffee or whatever and come back later. An alternate way to do it is to use PV, pipe view, and that gives a little progress bar. I think it's pipe view, maybe it's progress view, I don't know. That's what main pages are for. So the PV does not come with Kali, so you can do apt-get install PV to download it. It's a Debian package, just not pre-installed. So again, not to be confusing, but we're using Kali to make Kali bootable. So in the virtual machine, I would have to do an apt-get install PV. And it's already installed, so it's not going to do anything. All right, so PB works like cat. So if you're familiar with the cat program where it just prints out whatever you tell it to print out, it operates in a very similar way. It takes input from standard in and standard out, unless you specify a file name. Okay, so we're going to say copy media shared folder, Kali, and PipeView sends its output to standard out. It's just going to print it to the screen. So instead of having it print the contents of the ISO file to the screen, let's redirect it over to dev SDB. Okay, and then you'll get the little progress bar by default. It usually does take a while. While that's running, I can point out that if the device that you plan to connect to your virtual machine is USB 2, then in the USB settings down here, you can check off, it's grayed out right now because the virtual machine is running, but you can see that okay. It's enable USB 2 controller, and assuming the device is USB 2 capable, that greatly speeds up the data transfer rates to your virtual machine. Now, I have seen problems online where people were having all kinds of problems and they were trying to hook up like USB 1 scanners to their virtual machine, but they had the USB 2 box checked off and the scanner's USB 1, and they're having all kinds of problems and nobody knew what the answer was. That's the problem is the device has to be USB 2 compliant. Otherwise, if you want to be safe, just uncheck the box, but know that you're going to drop the transfer speeds down a lot. All right, so we're about 87%. Is there any questions about anything so far about the virtual machines or copying the files or where to get the files? Adrian? PV command's new to me. Does that act just like DD, or can you use it for anything? I mean, what all? It's not nearly as powerful as DD. But if you happen to be dealing with a file, it's good because it takes files in, any kind of file, but in via standard in or by the file name, and it just sends it to standard out.
Okay.
So it's a very similar. It's very similar to cat. I would say the difference between PV and cat is just the progress bar. As far as I can tell, the PV has got a lot of built-in, like it's got this built-in number of bytes and these little timers about how long things are taking and stuff as well. Whereas cat would just say what it's trying to say, and PV says it, but also gives you the progress. I guess technically you could even do like cat file name pipe PV redirect as well. It'd be the same thing.
I was just curious because I haven't played that before. That's nice.
It's generally used between two commands because you would do the first command and then you would pipe it to PV and then pipe that to the last program, the last command. So you kind of think of it as while the data is going through the pipe, it's just giving you the progress. It's the best way to look at that program, I think. All right, well, I think it thinks it's done, but I don't believe it's actually done, so we'll just wait a minute. It seemed like it went kind of fast.
Is it indicating 16 meg or is that per second?
It's transfer speed
Per second.
per second. Yeah, the file is a couple of gigabytes,
Right.
so it's going to take a while. Yeah, actually it looks like it's 204, so it is bigger than, slightly bigger than 2 gigabytes. If this doesn't work, we'll go back and use DD pretty soon, so we don't take up too much time. But when I tried this, I think it was yesterday, I actually just set the command off and then walked away and came back in like an hour. I had no idea how long it actually took. So. Looks like it cannot interrupt it either, so if you're very impatient like I am, you'll have to just kill the terminal. So. Alright, so we're going to do DD input files equal to media shared and Kali, and then the output file is going to be the device. Block size is 512. I think it's the default anyway.
Jeremy, I've never tried this, but can you also do that with like the SD cards? Is there a boot?
Mm-hmm. Yeah, probably. It would depend. It's going to depend on all those same exact assumptions we already had about can you get to the BIOS configuration, can the device boot from the SD card. Some devices can, some can't. Off the top of my head, the one I could think of that would definitely boot would be the Raspberry, because it actually uses SD cards. It's hard to.
And I noticed I got a netbook you can boot from the SD on.
Okay. Yeah, definitely there are devices out there that can. It's just.
The Nook I have that I play with that boots from the SD card.
Okay. I don't think that just because the device has an SD card, it would necessarily boot from it. It just depends on the BIOS and if it's a bootable device or not. So there's not much difference between exactly what we're doing here for the USB and setting up the SD card for, say, the Raspberry or perhaps the Nook. The way you would do it is, if you're in Windows, use Win32 Disk Imager to image the card. If you're in Kali, you would use DD to image the card. That's assuming the card's already clean, there's not a bunch of partitions already defined on it, otherwise you're going to start overwriting partitions and the results may vary in a bad way. Okay. All right, well, we're just going to assume this is done because it's taken a while. I got another USB that's already made up. And we're going to use that.
This is like one of those cooking shows. Well, I've already cooked it.
Yeah, exactly. Chicken.
Pulling it up.
Santa Claus.
Considering this is chef's too.
Okay. And yeah, it looked like it had a while to go. As you can see, it was like only at 901,000 bytes, so we needed to go mobile on or something. All right, let's see if this other USB is connected. I have a feeling it is because in the background you can kind of see how it was mounted. And there you go, now in the file system. All right, so let's just assume that the Kali Linux was copied all the way over. And then what we're going to do is we're going to start gparted again. And it turns out this other USB happens to be called SDB as well, so it's worked out that way. Okay, so we can see we've copied the Kali live, and if this USB wasn't already done, this would still be unallocated space over here. But what we did is we right-clicked and we selected New Partition, right here where it says New. And then we very carefully gave it the label of persistence. And be careful, there's no A in persistence, so yeah, you do have to spell it correctly. I'll explain why later. So now we have partition number 1, which is just that ISO literally copied bit by bit to the drive. And then we have partition 2, which is an ext4 file format. So you have to be careful too when you select new, and then you go to fill out the parameters, the name, the label has to be persistence, and it's best if the file system is ext4. It doesn't have to be, but it's most compatible. Okay, and then we would hit the green save changes, and we would have this persistence volume. Turns out there's about 5 gigs left over on an 8 gigabyte device, roughly, for your save your changes. Then what we would do is we would make a file called persistence.conf as a configuration file for the persistence volume, where we could say what parameters we wanted. So we can say echo the root partition. We want it to be a union persistence, and we would send that to the device. Actually, we haven't mounted it yet. So let's see. Let's go to the mount directory. Okay, we have an SDB2 folder already. Otherwise, we would do a make dir SDB2. And let's mount it and then send the file to there. Okay, it's already persistent like cough because I've already made the file. But we would end up doing an echo / union, excuse me, echo / space union. So you do something like that. Or you could change directory into SDB2 to make it less complicated, and then just say echo / union into persistence.conf. And that'll create that file for you. Or you can do it any other way. You can open up a text editor and save it, or use any other method, but you need to get that 7-character string into the persistence.conf file, and it has to be in the root of the partition. So we've mounted this SDB2 partition into the SDB folder, SDB2 folder. So that persistence.conf file needs to be right there, right at the very top. Okay, and then if we look at the contents, it's just / union. So is there any questions about creating that file, or how to mount a USB partition onto a file system or anything like that, or how to create the file? You can use a GUI editor too if you want, LeafPad or whatever. It doesn't matter how you get it in there. You just need to create that file. All right, and at that point we're almost done. So we need to shut down the computer. In this case, the virtual machine. Well, actually, let's unmount everything just to be sure. I don't want to lose any make changes and then not know why things are blowing up. Okay, next we're going to try to boot from this USB and see if we can get this laptop to use that operating system instead of the host. Do not format the disk.
Why not?
At least not until the demo's over. Okay, be interesting to see if Adrian's screen capture can still see all of this here after we boot to the USB.
I'm watching the bind out.
All right, we're still plugged in, so
Uh-oh.
everything seems to be plugged in okay.
This part goes to a knockout, but hopefully in a second we'll see.
It's a very angry USB. Okay, we have the boot menu, and we're just gonna.
Okay, unfortunately, it looks like I don't think it's the rig either. It's saying it's HDMI. Doesn't necessarily. It's not turning on the HDMI port when. Well, actually, you're doing the VGA though.
Yeah, VGA. You're
Is
right.
it not turning on the VGA then? Because I'm pretty sure even if we went direct, that wouldn't make a difference.
Okay.
Actually,
Oh,
There it is. Oh, it had to get into that
Patience.
VGA mode. You know, that when it starts, it's in
Right.
that.
oh, and it's up.
It's in that other mode. So, trust me, it was spectacular. Okay, so now it seems to be just working like normal. So that's it. We've booted into the USB, and if you don't care how any of it works, and it's just pretend it's all magic, and you're done. So
If you have a device that can boot from a USB in a different web fashion, is there a reason to create the persistent? Like, can you do an install? You can install it, point it at the drives that are represented by the USB, and have it function properly, or does it cause problems as far as? I know I hate it. Booting OS off certain flash storage devices causes problems from the standpoint of wear and tear of constantly writing small files, and maybe this takes care of that. That's why I was wondering if this part of the purpose of this was to keep writing all those little files over and over and over again, which my understanding quickly deteriorates NAND flash.
well, you can. My understanding is you can have persistence on a completely different device, and so you could boot from the USB and then use persistence on the other, whatever the other device is, whatever the other mountable device is. So you don't necessarily have to do it the way we've done it today, but if you want to have everything all in one USB stick, you would have to do it like we did today, if you don't want to have two things.
You can do both, can't you? I think there's some options where you can move it after you boot up. You can move it to a temporary spot on the hard drive in the device. if you
Yeah,
want to.
you can say, I'll show you all that in a second. You can say source equals, and you can move the, yeah. It's
Yeah.
kinda neat. It is cool. So, okay, so let's, all right, now using the actual Kali Linux is completely up to you, so we're not covering any of that. So good luck. All right. I am going to shut this down, and then we're going to go back into the virtual machine, so we're going to mount the USB as just a regular drive, and so we can look and see what actually happened, what's going on with that persistence on conf, why did we say /space union, what was the point of all that. Okay, reboot.
Do you have a USB 3 thumb drive yet? And I
No.
don't know if you have any recommendations for something faster. I've used something called USB D-View from Nearsoft, and he keeps records of how fast different USB devices are, because he has a feature built in that says, read this much data, write this much data, and send a report to my website. So that's a good place to check out for fast drives, but I was wondering if you could recommend any particular, because I know some thumb drives are just so piss poor slow, it's impossible to want to use them for this, and other ones that have been decent.
Basically, I got to admit my budget is like near zero, so I've got like all the like $8 stuff. I haven't got anything USB 3 or anything even
Walmart.
fast at all. So
Walmart Technology Department.
that's it.
You
Yeah.
need a lot cheaper other places than Walmart.
I was gonna say 16 gig USB, big lots, $10.
Yeah, this one was given to me. Actually, I think both of these were given to me by University of Louisville. I did a class for them, and they were like, "Here, have some USBs." So
I like these little Picos because you can
They're tough, and you can put them in your pocket of your wallet,
Oh, there you go.
and
Stick
they don't break. Whoops.
Yep.
They'll still be fine when I pick them back up.
Yeah, right. You got two of them? So,
Yeah, I actually have a few of them around home.
No value.
so that is
16 gig, I think.
16 gigs, super talent brand.
And they don't seem too slow. These are USB 2 ones, but
New X triple today has got one on there. I don't remember which it was. Very small one.
Oh, yeah.
they don't break my shit on them.
And don't format the disk. So I guess you can notice that Windows is not recognizing that the USB has a file system on it because it's Linux file systems. So it keeps asking if we want to format the disk. That's why that box is popping up.
Just say no.
So, yeah, just say no. So we'll do the VirtualBox, get the VirtualBox running, and then we'll get Kali running so we can go back into our environment. We've already talked about all the filters, talked about how the host sees the USB first, of course, and then VirtualBox takes over from there. Looks like VirtualBox has already grabbed the device because of the filter we set up. There's already a check mark next to the device's name in the devices menu on the VirtualBox console. I guess one tip for demos is use a much faster computer.
Also, these big plasmas or LCDs are a bit problematic because you throw any resolution on it they don't like, they do all sorts of weird stuff.
Mm-hmm. That's true. Yeah, if you're using Kali in a virtual machine and you're having resolution problems because, like in this case, the projector or the television is having trouble, just when you log in, just give it a minute, it'll readjust. So it looks like it's more or less kind of okay. So we open a terminal and put it back in the center where y'all can see it. Is that good? All right, there we go. Okay. All right, so the message, and somewhere in that mess is this SDA stuff. So let's see if we can figure out which one's which. SDA, SDB. Okay, so SDA is probably my primary hard drive because it's got all these different, it's got SWAT mounted on it and stuff like that. And SDB is probably the USB because it's got an ext4FS on SDB2, which we built. It all kind of makes sense. Let's go into mount. We have the SDB2 directory already, so we'll mount device SDB2 to SDB2, and then ls into SDB2. Oops, getting CD into, and then ls the contents. Okay. Well, either way, there's persistence.com. So I'll put these notes up on the YouTube or wherever we end up putting this video. Probably on Rapid7's community site. So I've got some notes in here that you can refer back to. But essentially what we're doing with persistence.conf is we're creating a custom persistent mount. And it's in the format of the directory that you would like to persist, and then the options of how you want to persist it. Well, looking back in our example, we said that we want to persist the whole entire thing. We're just persisting the root file system, okay, everything in it. Didn't have to do that. So for example, maybe we would want persistence.conf to be /root, just your home directory while you're in Kali, or whatever other directory it is that you wanted to persist to save off. And we passed in an option of union. So by default, if we hadn't said union or said anything, it would have actually mirrored the entire root directory. So it wouldn't just keep the files that were different. And that option is called a bind mount. That's the default option. So by putting in the union, what we're saying is well, if something changes while we're using the USB, go ahead and write those changes down. But otherwise, we'll just assume that the next time we boot up, we'll keep the unchanged stuff from the first partition that Kali's running on, and then we'll just have the changes merged in from the second partition, SDB2. You can change the source path. So in other words, we picked root, but if we wanted to still save root, but we wanted to save it under a folder in SDB2, so that perhaps we could persist, say, like two totally different operating systems or something like that, but on the same USB drive, we could create a folder like my operating system 1 or whatever, and then persist the root of the first operating system under that, and then create a separate folder for, say, operating system 2, and then have the second root persisted under that. So you can have two different devices stored up. So that source equals path would be an option that we would put in the persistence.conf file. So it'd be kind of like this, where you have like a comma, and then you would say, you know, source equals whatever. So if you put two different options in here that are not compatible with one another, like say you did like union bind or something like that, which makes no sense, right? Because how can you only save the changes and also save everything simultaneously? It'll automatically take the last option you specified. So in this case, it would bind it. So if you make that mistake, that's what's going to happen. So I guess in the notes here it says, on conflict, the last option wins. So the source directory, we didn't create that on SDB2. If you remember, we just created that file and then we were done. We booted, and then all these other folders were brought in. So those folders will be created automatically for you if they're not automatically created. And they call that, basically it's, when it's in bind mode, it's called bootstrapping. So if you were in bind mode and you went ahead and booted, the entire root directory would have been copied over to SDB2 automatically if it wasn't already there. And then as you worked throughout the day, any changes would have been persisted over as well. So on the persistence volume, that mirror is called the source. Sounds kind of backwards, but if you think about it, it's the live, from the live CDs or live USB's point of view, it's the source where it gets all the changes from the last time that it was running. Okay. Now to actually use it, I'll show that here in a minute, probably at the end. But in order to actually use the persistent volume, we need to when we boot, we need to change the boot parameters. And I don't know if we're going to be able to catch that on video, but if you go out to the Kali website and read their documentation, they have a great screenshot of how to do that at the very bottom. You can just scroll down, you'll see where to enter the word persistence. All right, so let's see. We'll do a demo now, and what we're going to do is, since we're not going to be able to see these notes, is we're going to look at the volume with the union parameter, and then we're going to change something in the live boot, and then come back later and look and see that it was actually persisted out to the disk. And then we can go ahead and cover how to do this in Windows now while we still got, we're not booted into the USB. So in Windows, there's a program called Win32 Disk Imager. You download Kali, just like you always would. put it somewhere where you can find it. And then you would select that program from wherever. So I had actually done this recently with the Raspberry Pi image and saved it out to the SD card, because the SD slot in my laptop is not virtualized in the Kali, so I couldn't do it from there since the virtual machine can't see the SD card. So in that case, I had to do it in the host operating system. So I would pick that file, and then I would pick the device to write it to. I don't have an SD card plugged in right now, but if I did, the device would appear in the list. But again, just as in Linux, be very careful about which device you're actually going to write this out to, because you're writing it bit for bit over top of the physical disk, and you will wipe out disks if you're not careful. Adrian?
In the Linux version, you put how to refer to, you know what they say DD stands for? Data destroyer.
Data destroyer, or destroy disk. So, okay, and then you would say, there's a button down here that says write, and you would say write, and it would write it out. So, now how to actually create the persistence volume in Windows and all that is up to you. So, the way I always do it is I get the disk set up with the Win32 disk imager when I have to do it in Windows for whatever reason, like the Raspberry, for example. And then I actually boot into a bootable USB and use that to do the rest of the changes if I need to do that. So in the case of Kali on Raspberry, you get kind of lucky because they had the foresight to set the SSH up for you. So you don't actually have to have like a physical keyboard and stuff hooked to the Raspberry. You can just plug it into the Raspberry, plug the Raspberry into the network, and then go to your host and SSH into it and take it from there. We might do that in a later lab. Okay, so in order to show you the next part of the demo, I've actually got to get out of Windows and all that. So we're going to come back up here to this first part, look at the live changes. While I'm doing this, is there any questions about the material that we covered so far? Okay, so we'll restart. We'll use the persistent volume to save off the changes, and then go back into Kali and look at the changes. All right, so we hit Tab, and that opens up this boot menu at the bottom. So we're going to enter a space, and I guess you all can't see anything, right? All right, so you hit Tab, and then there's the boot menu at the bottom, and then you hit space, and you have to type in the word persistence. So do this way. You literally get this menu, you hit Tab, and at the bottom of the screen there, you type in the word persistence. Don't forget to put a space, because the cursor's right on the edge when you bring it up. Again, there's a picture of that for people watching the video on the link provided earlier. Okay, and you hit Enter. The persistence, of course, is the label that we gave the second partition. So the live boot system knows to go look for that persistent volume when we type the word persistence in, when we type the label name in. And it's also automatically, when it finds that volume, it's going to look in the root directory of that volume, and it's going to look for a file named persistence.conf to get its instructions from. So the reason we had to be very careful about what we called the volume and what we named that file and what we put in the file is because this is all sort of hard-coded into the boot process, and it's going to be looking for those items. So right now we're booted into the USB, and we should have persistence. We can see persistence is mounted. It doesn't need to be. It just is because it's a USB device that's been recognized. And we also notice STB1 is mounted as a read-only external device with the CD symbol. All right, so let's go to, so where are we at now? We're in the root. We'll remove test file, and we'll echo everybody to this test file. So we've just made a change to the operating system. We've changed the file system, I should say, to be more accurate. Okay, we'll shut down the OS that's coming from the live boot, bootable USB. USB out, restart the laptop. Were you able to run the Kali on the NUC, by the way? Did that work?
I actually have it set up to do dual boot, so I can actually triple boot.
Okay.
So I can boot it as a NUC, I can boot it as actually backtrack when I put it together, and also run it as an Android tablet by itself.
Now, you have to actually directly booting in the backtrack, or is it like a change root environment?
It's a change root.
I know that in Kali, they're starting doing a lot better job of actually making the ARM distributions be really ARM distributions as opposed to just a change root environment. Try playing on the Raspberry Pi, it's actually decent speed. They're not using the hardware floating point because Debian, normal Debian doesn't, but it still responds decently fast. And if you really want to, I suppose you could build the tools yourself on top of Raspbian, and then you get the benefits of the hardware floating point.
Yeah, I didn't notice any difference in speed between the Raspberry operating system and the Debian 6 operating system.
We're using Raspbian. That's the one that's Debian that's compiled specifically for the hardware floating point that's built into the.
Yeah, that's a good question. I just got the one off the Raspberry.org website.
Okay, they've started recently at least defaulting to using the Raspbian one.
Oh, okay. Let's see here. I think VirtualBox is already started. Wait a second to see. Okay, so we've covered the boot live. We've covered half of the changes to persistent volume of the union, and we covered the Windows part. Check devices and see the USB is still mounted, auto mounted, I guess, thanks to the filter, at least auto connected. your virtual machines to load a whole lot faster, use SSD.
Yeah.
I think I've got the only 5400 RPM drive that runs at 1200 RPM. So let's see if there's anything else going on. Doesn't look like it. It's just slow. Okay, I'm gonna CD into mount directory, mount USB. Again, same thing we've been doing. Used to be 2. Used to be 2. See if I can shut down any services or anything. Let's try to turn off the antivirus for a second. Not quite sure what's making everything so slow. Looks like the USB had some kind of problem mounting this time, so I'm gonna give it another try. Okay, sometimes you get lucky. That seemed to work. Okay. All right, so if we go into the root directory, we can see it's kind of highlighted here, the this.test.file that we created while we were booting into the USB. We can cat contents, and there's the hello everybody that we put in there. So we can see we persisted the file across the boot, across the session, and saved it out to the drive. Just for the sake of time, I'm not going to demo the other option of actually mirroring the entire drive, but when we actually boot into the operating system off the USB, it would be what they call bootstrapped, or would be copied over at that time, and then any changes that we made during the session would be mirrored. And so you would see the entire operating system, or excuse me, the entire file system mirrored instead of just the changes. If we go up one directory into the root, we can see that the only thing that we're mirroring is the etc live root temp and var, because while we were in that, booted into that USB, something, at least one thing in all of those different directories was changed. So you can imagine in var, probably the log files, for example, were changed. So, all right, is there any questions on anything we talked about so far? On that boot menu, let's see. If you're booted into the USB, while you're in the USB, this SDB2 volume that we're looking at now will be mounted under, I think it's the live persistence directory. So you can actually go into that persistence.conf while you're booted into the USB itself and change the persistence.conf under that directory tree. It's like live persistence. So, all right, any questions about how any of this works? Okay, thanks for coming today, and that is the end.
sorry?